So if I were to say, determine the sixth roots of unity, I'm basically saying the sixth roots of the number 1. And the number 1 is technically 1 plus 0i. Right? So I'm asking you to take the sixth roots, find the sixth roots of that. So that's a little tricky, but we know to use de Moivre's theorem, which is anytime you want to do a power or a root, I need it in trig form. And if I put it in trig form, I need to have the magnitude and the angle. Now, do I need to use my formulas for magnitude and the angle on something like the number 1? Hopefully not, because the not magnitude, absolute value. The absolute value of the number 1 clearly is 1. And by the way, if it ever is something that is pure imaginary or pure real, do you guys know that you just drop the negative and drop the I? Like for instance, if it was up here at 2, if the number was 2i, isn't the distance there 2? So absolute value of 2i is 2. If the number was like -4, we know absolute value of -4 is 4. If the number is like -6i, the distance is 6. So if you ever have a pure imaginary or pure real, you just drop the negatives and the i's, and that's your absolute value. The only time you need to use that square the real, square the imaginary, add them together and square root is when it's not pure imaginary, when it's over in one of these quadrants. Then you have to use that, but basically the Pythagorean theorem. So in this case, absolute value is 1. So I've got 1 out there, and then what is my angle? Remember cosine, CIS means cosine theta plus I sine theta. It's a shortcut. What is my angle if the thing is right out there at 1? What's that angle? 0. And if it was something like 5i, the angle's 90. If it's something like -4, the angle's 180. If it's something like -7i, the angle's 270. Right? Okay, so the angle is 0 degrees. Now remember, that's not my first root. That's unity. Okay? So how do I find the sixth roots of that? So if the sixth roots would be the first one would be what? The sixth root of 1, and then what do you do with the angle?
Multiply by 6.
That's what you do if I'm raising it to the 6th power. So you're really multiplying it by 1/6, or dividing it by 6, because the power of a root is a 1/6 power. Right? So de Moivre says raise it to the power, multiply by the power by the angle. So if the power is 1/6, I multiply the angle by 1/6, which gives me, theta, which is 0/6. Now, it turns out on this case that I do end up with that. But the only time I end up with the same thing I start with is when I'm dealing with unity. Any other time, or a pure real number that's like a positive pure, like 8, 6, anything like that. Those don't change even after this. Actually, I take that back. The only time would be unity, because you would root something like 8, and that would change. So how do I find the next 5? Why am I adding 60? Because 6 into 360 is 60, so they're spread equally 60 degrees apart. So the difference between this one and the second one, third one, fourth one, fifth one, and sixth ones are all going to be 60 degrees. So I'm just going to add 60 each time to this. And every year I get somebody who gets off on their adding. If you get off on your adding, like if you're going, 0 plus 60 is 50 or whatever. If you get off on your adding, just take the last one, add 60 again, and you should be right back where you start. Because if I add 60 to that, I get 360, and 360 is in the same spot as 0. So that's a nice check for you. There's no reason for you to get dotted on something that you know how to do. Okay? That literally is like me taking off 25 points off your test. I mean, who wants a 75C? That's what ... just gave you. It gave you a 75C on that problem when you knew what you were doing. Just because of carelessness. So don't get off on these angles. Make sure you're careful. And if I say leave it in trig form, you're done. That's trig form. It's a shortened version of trig form, but that's trig form. And then notice the magnitude, the absolute value of 1 right here. I don't have to put 1 out front, but that doesn't change on any of these. Obviously, you don't have to write it if it's the number 1, but if it was something else, like 2 or 4 or whatever, you just write that all the way down. So that was unity. But remember, a lot of people forget to divide that angle by something. If I had said, if my original number, if it wasn't unity and it was something like 2 CIS 30, yeah, and I said find the 6 sixth roots, you're going to have the 6th root of 2, which is never going to be pretty, right? You can't simplify that. 6th root of 2, 6th root of 2, 6th root of 2, 6th root of 2, all the way down. And then you're going to divide 30 by 6, and that's going to give you 5. So then when you come in there and start adding these, 65, 125, 185, 245, 305, and if you add another 60, you're back to 5. So do make sure that you get this part right. This first one right there is your most critical one. That's like half your credit right there. And then these, because this is, you're not doing much for the rest of these. Sometimes it's 3/4 your credit. Because really, what are you doing here but adding a bunch of that? I'm just checking that number. And then on the word problems, I'll set it up for you, and then, but I don't want to do all of it because I want you to think through these. The math anyway. And then I have one more that I want to talk about. Okay. Okay, so it says a surveyor wishes to, and I think, oh, this is cool. Like, for instance, I used to be able to look out my window and see the clock tower at Sanford and use that as an example, but I can't really do that now. But anyway, I could do this. I can determine how far away I am from one of those trees without measuring to the tree. Just using law of sines and cosines. And I can stand right here in the room and do it. Okay, think about it. Here's the tree. And say, here's me at point 1. So we'll call this point 1. Okay? So what I can do is I can mark this spot and then walk over there to where Narcissa is and mark that spot. Now I'd still have to be able to see the tree, so whatever. I'd go and mark another spot. So that's me at point 1, me at point 2 over there by Narcissa. And I would just measure this length from here to there. So say I measure that length and it is 20 feet. Okay? Then all I have to do now is calculate the angle right here. And honestly, I could do that. I could draw a line on the ground. I could draw a visual line from there to there, and I could measure that angle with like a protractor. You with me? So I could pull out my protractor and measure that angle, and let's just say I found that it was, I don't know, 82 degrees. And then I could come back over here and draw off this visual line, right? Just kind of literally mark that visual right here, take that angle right there, and then calculate that angle. Let's just say I calculated this angle and I got 77 degrees. What do I have? Angle, side angle, and if I have two angles, I always have the third one, right? Which in this case would be, what, 21? Feels wrong, but I think it's right. And now I have all my angles. So what would you do if you needed to find, this was me at point 1, like right here. How do I find that distance? What would you do? Law of sines, so you would say sine of 82 over that side equals sine of 21 over that side. And I literally can find the distance there. I've always been fascinated about that. That's what surveyors used to do. Now they have equipment. And they'll just take their equipment. It's like, you know, it's like a golf. If you play a lot of golf, you can buy those little range finders, and it kind of finds out exactly how far away you are from something. But in the olden days, my dad did surveying work when he was in college just for extra money. But that's what they're doing. They're just using geometry, and they would set up lines of sight, calculate angles between two fixed points that were relatively close apart, right? From here to there. And they could determine how far apart something was without going and just taking a tape measure and walking for 2 miles. And they literally could do acreage and actually do surveys like this. But I always thought that was kind of cool that you could do that without really moving anywhere. And you got to be careful to get pretty accurate angles. But that's possible, right? But nowadays that equipment, you just set up there and you take a little laser and it measures the distance. There's probably sonar kind of stuff and calculates stuff. Who had their hand up? Somebody did.
I was going to ask why they didn't just measure with a tape measure.
Yeah, from here to the tree would be tricky though, right? Because you'd have to measure here and then you have to go outside and then measure there. But if it was 2 miles apart, big tape measure, you know? But like if I'm ever doing a course, like there's other ways of doing it. Like if I remember like having a race and I'm trying to mark off a 5K, most people have these wheels and you literally just walk along with the wheel for the route and you're taking distances that way, which is fine because it's not that big of a deal to walk along with the wheel and let it calculate the distance for you. Or now there's GPS. It's like on my phone alone, I can just sit there and it'll map out my distance on my phone and trace it. But in the old days, we didn't have all that stuff, so we use math. Yes?
Also, are there going to be this many D&Es on the test? Just 3 out of the first 4 D&Es.
I'm not sure that, double check the key. Is that right on the key?
Yeah, they're all.
Yeah, so maybe not. Seems like there's always at least a couple. Well, I can't say that. There will be at least one, I'm sure, because there are conditions I'm trying to see if you are checking the right stuff. And there are certainly some things I like to check that way. And then that other one said, so that was kind of this problem if you think about it, right here. And then the second one says 2 hunters, Biff and Buffina, are sitting in tree stands 100 yards apart. So we got 100 right here, and then here's a tree stand. You see. Now here's the problem. Don't draw a tree stand like this and have the guy just, sitting down, holding his rifle or whatever. I'm not talking about that. I'm talking about an overhead look at this. So let's just say we're looking from the top, and here is Biff, and here is Buffina. And they're 100 yards apart. It says Biff spots a deer at an angle of 25 degrees from his line of sight of Buffina. So if Biff sees a deer, and it's 25 degrees away from his line of sight, you with me? It could be either there or there. I'm just going to pick going up, or not up, but going left, I guess. So it's saying that's 25 degrees, and I spot some deer. And it says Buffina spots the same deer at an angle of 32 degrees. So her angle's a little bigger. So I guess the deer must be somewhere like right there. But her angle was 32 degrees. And it says, how far is the deer from Buffina? So you would be looking for that distance. Now technically, you can get 2 situations right here from this picture. Have you thought about it? How I could get a different situation? What about, I'm going to have to change my angle. My picture's a little bit to get them on this picture. Technically, $25 degrees. Actually, that's not true. If I didn't say from her line of sight, this is not true right here, because if I say from the line of sight, that means she has to be looking at Biff and marking it. But if I just said with an angle of elevation, like if I change that from line of sight to angle of elevation, and you remember what angle of elevation is, right? Yes, no? That would be angle of elevation. Technically, this could be the deer also if I had said angle of elevation. Because But that technically is not true too, because if I'm looking from an overhead view, then that would be angle of elevation. But let's just say I said I spot a bird flying. So what if I spot a flying bird? Well, I could spot a flying bird with an angle of elevation of 32 and 25, and it could look like that, or it could look like that, couldn't it? Are y'all seeing that? Yes, no? So technically, I could have had two images there. Interesting. But not on this one, because this one said line of sight. That means I have to be looking at each other, right? Line of sight. So in this case, this was the only option. And I probably am not going to try to make it like the one I'm just suggesting with the angle of elevation or line of sight. I don't see me doing that. It actually did that to you last year on a homework problem. If you don't check your homework, you might not have caught it. But that's what I would set up. So if I'm looking for how far is the deer from Bethia, and I'm looking for X, what would you do here? All signs again. Sine 25 over X equals, so I gotta find B up here, which would be what, 57, 123? Sine 123 over 100. Solve for X. All right, I got one more I want you to look at. I think it's on here. Okay, maybe not. I'll do one similar. All right, check this out. Make a good note of it. Might be on your test. So this is just a random problem. Random question. What if I gave you and said simplify? I'm thinking of two options right now. Well, three. The third option, which I hope nobody does, is literally write out 1 minus I 24 times and get busy for it. Probably not in your best interest if you'd like to finish the test, but hey, you never know. I've had people try it before, with rarely have any success with it. And then of course you're gonna have to do the denominator too. Anybody else have an idea?
Use the theorem.
The Mobley's theorem?
Yes.
Okay, so right now I have stuff in standard form, so I would have to put it in trig form. So how do I put each of these in trig form? What do I need first?
The magnitude.
I need the absolute value. And what's the absolute value if I'm going over 1, down 1? Root 2. And you know that from basic geometry, right? 1, 1, root 2. And what angle would I have on that, by the way? What? Careful, over 1, down 1. Negative 45 or 315. Doesn't matter to me what you use, but considering that I'm about to raise it to the 24th power, negative 45 might be a little bit better, but you're welcome, because I'm using, remember, I'm going to multiply by 24 on the Mobley's theorem. Might be easier, because you're going to end up with a really big angle at 315 times 24. But either way, absolute value would be root 2, and then CIS, negative 45. Now I'm doing all of that to the 24th, and while we're at it, what would this absolute value be? Over 1, up 1, also a root 2. And that would be to the 45 degrees. Now, what if you have no idea that that's 45 degrees? What would I have done to find the direction angle? Inverse tan, y, which is the coefficient of I, over the x, and don't forget to add 180 if necessary. But neither of these do you have to add 180. So how do I apply de Moivre's theorem now? By the way, this is not the easiest way to do this, if you happen to see this or this, but what could I do? And it's fine to use de Moivre's. What would you do here? So raise the root 2 to that. And then what? And then the angle negative 45 times this gives me 1080. Think 120, 96. Yes. So negative 1080. On the bottom I have root 2 to the 20th. And this time I have 45 times 20, which is just 900. Now, how do I divide complex numbers? Literally, we have a rule for this. We even been naming them Z1 and Z2, but how do I divide Z1 and Z2? Say it again. Put the magnitudes over each other. So I have to do this. I mean, we have a rule. Okay? So now that I have these complex numbers simplified, to divide two of them, you divide their magnitudes. So by the way, what is root 2 to the 24th the same as? 2 to the 12th. Why? Because root 2 is 2 to the half, power to power, boom. And then what is root 2 to the 20th the same as? So it says to divide the magnitudes and then do what? Subtract the angles. Now, one option you could do is make these positive first and add a bunch of 360s to make it positive. Subtract a bunch of 360s to make it smaller. You could do that, or you can just stick with your rule that says CIS negative 1080 minus 900 is negative 1980. And can I clean this up now? What would you do? So all of this cancels except for a 2 squared, which is 4. What is my other one? Then what from here? Do I leave it? So I add a bunch of 360s. Since I don't want to add 360 that many times, what I'm going to do is add 720. And when I do that, I get to there, and then if I add another 720, I get, whoops, don't need to do that. I get to there, and if I add another 720, I get, what, 180? So all of this is the same thing as 4 CIS 180. And what is this if I simplify it all the way? 4 times the cosine of 180, which is negative 1, plus sine of 180, which is 0, and I end up with negative 4. Are y'all seeing that? For something like that, I don't know. It's possible. But I didn't, and it wasn't too awful. Mine, a little awful, but not too awful. And to go from here, actually to go from there to here, it's just a dot, dot, dot's worth. So if you at least got it set up, you'd be okay. That's only worth to me a point. To me, it's all about the math of it. Now, another way I showed you was if you happen to see 1 minus i's and 1 plus i's, is there a shortcut I've taught you guys? Yeah, and you don't have to memorize that. I don't think that's worth memorizing. I mean, I do because I've done it just for years and years, but 1 plus I squared is very doable. Square the first, that times 2. Square the last is plus I squared. The plus I squared is negative 1. That cancels and you get negative 2I. And if I do the same thing with 1 plus I squared, I end up with positive 2I. So what if I just rewrote 1 minus I to the 24th as 1 minus I squared to the, what? 12. And then rewrite that as 1 plus I squared to the 10th. Then wouldn't that be the same thing as negative 2I to the 12th? And positive 2I to the 10th? And then I can just do the math. I can literally just square these like they were variables. 12 negatives gives me a positive. 2 to the 12th, I to the 12th. 2 to the 10th, I to the 10th. All but 2 of those cancel. All but an I squared cancels, and 4I squared is negative 4. And that's the same thing I got the first time. And that's a nice trick when you see these 1 minus i's, 1 plus i's in there. You don't have to always go through de Moivre's thing. You know? Something to think about. Anybody else run into anything else they've seen that they don't like and want to talk about before I say goodbye? It's not even Monday and you're super quiet. You what?
We did something like 22 the other day. I just, don't remember all that.
So find the cube roots of that. So based on what we know about cube roots, now on something like that, finding cube roots of a number is saying what numbers solve that equation. You can actually do this with math. Well, I know de Moivre's theorem is math technically, but you can actually do this with just the algebra you know. Although I don't encourage it, because if it's not cubed roots, what are you going to do? But the cubed, like x is a root, the cubed roots that are equal to 27 are the numbers I get when I factor this. And do you remember how to factor a sum of cubes? X squared, 3 squared, that times that, same, opposite, always positive. And I get negative 3, and I get 2 imaginaries from the quadratic formula. So I can do it that way. But what we learned was, if I want to take a cube root of a number, I have to put it in trig form. Right? So what is the absolute value of negative 27? 27. And what is the angle at which negative 27 is located? Because look what happens if I do this. If I say inverse tan of y over x, and that's negative, where is the inverse tangent? 0. Now we've memorized tangents. Tangent of 60s, 60-degree reference angles give me the root 3's. Tangent of 30s, 30-degree reference angles give me the root 3 over 3's. Tangent of 45-degree reference angles give me 1. Tangents straight up or down give me undefined. Tangents of angles straight left and right give me zeros. So what angles would this give me if it ends up being 0? 0, 180. But inverse tan only shows up between negative 90 and 90. So this is 0, and you add 180 to it because it's negative there. Now, I'm not going to do that. I'm going to grab negative 27. Where does that show up? Straight left. And what angle is straight left? 180. So I hope that you don't waste a lot of time doing that on these pure real or pure imaginary numbers, because they're just easy to graph. If there's no, like a plus bi, if there's no 2 different parts, like 2 minus 3i, then it's either going to be 0, 90, 180, or 270. So I'm going to use the 180, and I'm not going to do that because I just know that it's located straight left. Now if I want cube roots, how do I find the first one? Cube root that, and what? Divide by 3. There's your first one. And then how do I find the other 2? What am I going to add? If they're always, imaginary numbers are always equally spaced around a circle, where are they, how far apart are the other ones? 120, because 3 into 360, cube root 3 into 360 is 120. Add a 120. Add a 120. And just to be safe, if I add another 120, I get 420. And when I subtract 360, I get 60, and I'm right back where I started. And if it says trig form, which this did not specify, I would stop. So, and I'm going to say trig form or standard form, I think, on every problem, so you will know. Standard form or a plus bi form means you'd have to go, oh, well, What is 3 cosine 60? What's cosine at 60? A half? So 3 times a half. What's sine of 60? Square root of 3 over 2 times 3. So that would be the first one. What's cosine at 180? Negative 1 times 3. What's sine at 180? 0 times 3 plus 0i. What's cosine of 300? Positive 1/2 times 3. What's sine of 300? Negative square root of 3 over 2 times 3. So if I said a plus bi are standard, do that. If I say trig, do not go further. Please save yourself the trouble. I'm not even going to look at it if you go further. I'm just going to look at this.
When you said put something in trig form, do you want it to be between 0 and 360?
Always.
Okay.
So yeah, don't like if this had been 1800, don't leave it as 1800. If it had been negative 180, don't leave it. Make sure your final angles are always between 0 and 360.
I was talking about number 10.
So on number 10,
So I wrote like negative 14.4.
the trig form there. So yeah, so what did you get when you did your angle?
When I plugged it in, the calculator was negative 14.04.
Okay, so assuming that's right, and what was your magnitude?
4 root 17.
So assuming I got to there, I would just go back and add a 360 to that to make it look a little prettier. When I add a 360, I get 345.96. So again, we're just making that look pretty. I'm not adding 180 out of necessity, like I do when I do inverse tangent. Inverse tangent, I'm not adding a 180 because I'm trying to make it pretty. I'm trying to get it in the right spot. It's because my calculator lied to me and told me it was in the first and the second when it was really in the, first or the fourth when it was really in the second or the third. So that's, I add 180 out of necessity. Here you're adding 360 like you're putting lipstick on a pig, kind of. I mean, you're just trying to pretty it up a little bit. Whatever. Never heard that expression?
All the time.
Really? It's an old man expression, I guess. But yeah, that's just like not chewing with your mouth open. That's just good mathematical form. Anybody else? Y'all feeling pretty good about this?
Solid.
Okay, good. Guess what we're doing next?
Conic sections.
All the way till, actually,
Sequence and series.
sequences and series. We're going to learn some new stuff with sequences and series too.
Are we gonna do probability this week?
Yes, and I know you guys have asked me, I know Cherokee's asked me about that because of the ACT. And so if you take the ACT between now, what did I tell you? I went to look, was it late January, February? February? So if you, you know, most people's ACT that counts is the last one. You know, it usually is not, but you know what I'm saying? Like if you make a 34 and you're like, I'm out, you know, I have seen people take it and then take it again and drop. Like my oldest daughter got a 32 and then she took it again and made a 31. She's like, I'm out. She was horrible in math. Well, she wasn't horrible, but she was not, she went to a school that was not great. She could have been really good in math, I think, but that's when I decided to pull on my other kids over here. But anyway, my other kids were horrible in math and then they came through here and ended up being pretty good in math, making like 35s on their ACT or whatever. But she was like a 26er. This means nothing to you, but I remember asking her in February, what's the integral of x squared? And she was like, wait, 2x. And I'm like, no, that's the derivative of x squared. She goes, I don't know. The integral of x squared is like so basic in calculus. And to not know that would mean you'd make a 0 on the AP test, which is not even possible, but that's how bad you are. If you can't do a basic integral, you're gonna get smoked. And she had an A in the class. That's how bad their math was. You shouldn't have an A in calculus. and not know how to take an integral of x squared. And when you get there, which will probably be a week and a year from now, you'll go, oh, integral of x squared, x cubed over 3 plus c or whatever, and it's not hard.